the Positioning Constraints command helps you add physical geometry constraints to control the interaction between the different parts in your model or your assembly. For example, here we have a robot which has various positioning constraints telling each of the arms to stay connected and to be able to rotate around their axis of rotation. So if we turn on mechanism mode, we can drag the front of the robot, and you can see that the arm behaves in a way you would expect it to in the real world. This helps simulate the robot's movement. A more simple example is this sheet metal door. If we zoom in, we can see that there's a simple concentric constraint telling those two holes to stay aligned. And then another simple distance constraint, creating a 2.5mm gap between the door and the wall. Now if we turn on mechanism mode, we can open and close this door. Positioning constraints are also a gateway to more advanced functionality, like we can see here with this mezzanine floor. When we resize this, all of the parts in the model are automatically updating for us. And you can see if we pull this downward, the frame is pulling the floor and the fence downward with it to make sure that it always stays on top of it. If we push it upward, the floor and fence are both being pushed upward by the frame because there's a constraint telling the floor to always stay on top of the frame. When it is resized in this direction, the fence automatically stays around the outside edge because it has been constrained to always stay around the outside. Now let's have a look at how to create positioning constraints. Here we have a very simple steel frame. Each side is linked to the opposing side, so that we only need to change one to have the other side update as well. You can see if we resize this side here, we get what might be an unexpected result, which is that the part here is not following the corner we'd think it might. Now, of course, it's very easy to reposition this using the tri-ball. We can just activate the tri-ball, hit the spacebar, drag this to the point or a point on the part, and then activate the spacebar or hit the spacebar again to activate the tri-ball, and then drag this into position and we're done. But of course, you may not want to do that every time you resize your model. And in some cases, you want to create models that can be automatically moved when they're sized. It's worth noting, however, though, there are also cases where you don't want to constrain models because, for example, if this wasn't the end piece and was meant to be a middle piece, we may not want it to move at all when we stretch these outside pieces here. Before we get started, it's worth noting that IronCAD's constraint philosophy is different to that of traditional design software. Traditionally, you often make all of your parts individually, and then at the end you mate and constrain them together into an assembly file. IronCAD allows you to model all of your parts in the same file, so you generally need constraints a lot less often than in traditional software. And important to note is that you don't need to constrain parts in IronCAD that aren't moving. You only need to constrain parts if you want to constrain them, or if you have moving parts that you want to simulate various different movements. So anyone who's constrained a model in a traditional system before will probably know how long it takes to have all the different parts in a model and mate and constrain them together into an assembly. Whereas in IronCAD, you can build all of your assembly in the same file with everything already in the right place, positioned with the tri-ball. And then only when you have parts that you want to constrain their movement, you add the constraints to those parts and those parts alone, not the whole model. So of course, this can save a lot of time because you can skip a lot of mating and constraining that might be needed in a traditional system. So it's worth noting that mating and constraining shouldn't be seen as the norm, what you do with every model, just with specific models you'd like to simulate movement or you'd like to reuse, like we will with this frame. Okay, let's get started in adding the constraints. I'll click on the Positioning Constraints tool, and now I can add various constraints here to my model. Note you don't need to select the constraint first. You can click in the model and it'll show you the various constraints available for what you've selected. What I'll do is I'll zoom in and click on this edge point here, and you can see the part I've selected has now gone transparent, which allows me to select past it, which can be useful in some cases, which you'll see later on. And now I'll zoom in and I'll click this point here. I'm going to make that a coincident constraint. Now if I press this OK button, it will confirm the constraint and exit the command. If I press this OK button, it will just create the constraint and allow me to create another constraint. For now, what I'll do though is I'll apply that and exit the command as well to show you what happens with just applying that one constraint. That's a coincident constraint. So a coincident constraint between those 2 points essentially means that that point and the other point on the other part will always stay on top of each other. But as you can see, if we turn on mechanism mode, and before I do that I'll actually fix this part in parent, which basically just tells that it can't move, and we need that if we want to show the movement in this case, but not always. You can see here if we turn on mechanism mode, when we drag this part, those 2 points are always staying connected, but it can kind of go in almost any direction still. So of course we need more constraints to control that. Now if we want to, we can turn off fixed in parent. But now I'll also tell you what this means. This essentially means the model is just fixed and locked in place. Like for example, if you imagine a doorway, the frame around your door can be fixed in parent because it is stuck in the earth and it is still. Whereas the door won't be fixed in parent because it will be moving. And to simulate things with mechanism mode, you generally need something fixed in parent to tell the system what part of the model can't move. You can see if I turn that off for this and we activate mechanism mode again here, when we drag this, they'll both move because there's nothing saying that this should be locked into position. So locking it enables you to see a better representation of the movement available of that constraint and those 2 parts. Now what I'll do is go ahead and add another constraint here. So this time I'll constrain this top section and add another coincident constraint. And now you may think that will be enough to control the movement. If we turn on mechanism mode, you can see that we can actually now still move this only in the direction I am here, only rotating like that, no other way. So of course, we do need one extra constraint to be added here. This time I'll add a constraint between these top 2 faces, which is an alignment constraint, which tells those 2 faces to always stay aligned. With that done, if we turn on mechanism mode, we now won't be able to move those at all. You can see I'm dragging the mouse here and there's no movement because it's now locked into position. Now I'll go across and add those same constraints to the rest of our model. Now, they don't have to be the exact same constraints, and of course if you have different geometry than the simple geometry I have here, you may want to use different constraints to constrain your geometry. There are many different ways to constrain the same thing. For example here, this time I might constrain it a little bit differently. I might use this front point and make that a coincident constraint between those 2 points, and then make this a coincident constraint, and then also add another coincident constraint to down here. And just for fun, I'll make this one different again as well. This one, I'll zoom in really close and press the Control-Alt key to select behind that and actually select that back face. So you can see that face there. I'm going to select that face and add a mate constraint. And a mate constraint is essentially like gluing the two faces together. And I'm actually going to leave that one just as a mate constraint and show you the behavior that that creates. So if we now turn on mechanism mode, you can see because those two have been kind of glued together, although definitely not with glue, of course, those two faces have been stuck together. It's only the faces, so it can still move and slide around like that. So of course we do need more constraints to position that. So I'll also add a coincident constraint up here and one down here as well. And lastly, we'll add it to this corner. And this way I'll add a alignment constraint to the top and a coincident constraint to that point there, and then a coincident constraint to the front somewhere here, let's just say there. Then I'll hit OK, and now we should have all of those constrained. And now if we size this, so we click down and we resize this model, you can see the frame is now following. Now we no longer need this one fixed in parent. You can see if we leave it fixed in parent, when we go to size in this direction, it'll actually move in that direction, because we've told the system that this one is actually locked. This is fixed on the earth, it can't move. So if we turn that off, now we'll be able to size in both directions. We can pull back this way, and we can also pull out that way to move this and resize it like so. Oh, actually this one is now being seen as fixed because we've got nothing fixed in the model. So it is basically just choosing a direction for it to size in. But as soon as we have anything else fixed or constrained, then of course it'll move based on that. But otherwise it will generally choose a way for it to be to move based on what constraints it has available. Now for this one, I'm also going to add in another part just to show another way of constraining things, or just more details in the constraints we chose. I'm going to drag out this part from my catalog, and as you can see, when I drag that out, you can see it's not quite in the position we want it to be. Now we can activate the triball, and we could position it that way just by dragging the triball to there and then dragging to match that face really quickly and easily there. We could also position that with the constraints, and we could move this out into empty space, which can sometimes be useful when doing constraints, so that we can really see what each constraint is doing as we select it. So now I'm going to add a positioning constraint here, and that is going to be to align this face to this face. It's going to be an alignment constraint. Hit OK. I'm going to add an alignment constraint to here, and then hit OK. Now you can see that's aligned. And lastly, we just need a mate constraint from this face down to this face. Change that to a mate constraint, and it'll be mated together. It's worth noting that selecting constraints on faces is generally a good idea because it gives you very easy control of the constraint. Whereas when you're selecting on an individual point, the constraint can generally move in a lot of different directions. Whereas when you use a face-to-face constraint, it's relatively obvious the function that will be applied when you mate that or constrain that together. But of course you can also do constraints with lines and with points as well as faces. But faces are generally a good one to use, as they're very predictable in how they behave when you constrain things. Now with that done, I'm now going to copy this part around our model. So to do that, I'll simply activate the triball, hit the spacebar, drag the triball to the midpoint, spacebar to lock it down again, right click the internal handle and do a mirror link to copy that part. And now I'll do the same again, holding the shift key to select both parts. It's worth noting here that I'm going through quite fast with this tribal operation because we do also have another tribal video which goes into a lot more detail on how the tribal works. With that done, I now want to create the various positioning constraints for these other parts here. So I'll quickly go through and create those. As I've already done them once, I'll go through and do these ones a little bit faster. So I'll align that, and then I'll also align that, and then I'll also mate that to there. It's worth noting here that when we're mating this downward, this could be mated to either part, and that's because those parts have already been constrained to align with each other. So it doesn't matter which one we select when we do that downwards mate. But if you had different geometry or different parts, you may want to only constrain to one face, either that one there or the other one over there. But in this case, it doesn't matter for us. And we can choose this one first this time if we want to, instead of the top one first. Then click that face. It's good to remember that when you click on something to mate or constrain it, it will make that part transparent, which makes it easier to select behind it. For example, if we wanted to select and mate and constrain these two faces together like we have been on the other parts, we could zoom in really close and then select that face under there. Press the Control-Alt key and select behind, select a face. Or we could just choose this face first, and that will make that part go transparent, so then it's really easy for us to see behind and click on this face. We'll create a mate constraint there, then we'll create an alignment constraint on this face, and another alignment constraint on that face, and then we'll hit OK. Now when I'm adding these, we could also add an offset if we wanted to. For example, if we needed a distance there for them to be 2 millimeters apart, or to create tolerance and various things like that. And there are various constraints available, including a distance constraint, of course. We'll then hit OK. And now that that's been done, you can see if we resize our model, it will now all be updating nicely for us. And if we resize these, they'll update as well. Now we're going to add this bottom frame to the top here. So I'm going to select on all of those parts, and in this case I'm actually going to assemble them into their own frame assembly. So now we can save that assembly to the catalog if we want to use it later, for example, just that part of the frame. In this case I'll delete that one. Now I'm going to click on this one, activate the tribal, right click and drag and copy it above our model here, or in this case I'll actually choose a link so it stays the exact same as the assembly below. With that done, we now want to mate and constrain this to stay connected to these parts. So I'll use the positioning constraints command again, and this time we actually need to add 3 constraints. Instead of 1 for every corner, we only need to do 1 corner. So we'll add to this corner and do a mate constraint, and then we'll just align this corner to the other corner here. And you can see that in this case we only need to do the constraints on that corner because this assembly is linked to this assembly, so they're going to match. So if it aligns with this corner, then it'll align with all the other corners. So we only need to constrain that once there. And now you can see when we resize our assembly in any direction, it should update for us automatically and stay connected. Note there are various other constraint types you can use here. For example, you can read through them here. And depending on what you're building, different ones of those will be useful. As a very quick example, I'll also go ahead and do a demonstration of using the concentric constraint to create a rotating part. I'm going to create a copy of this part over here. Actually, I'll create a copy of this part instead. Then I'm going to rotate this part with the tri-ball. To 90 degrees. I'm going to position it on top of our assembly in this case. Or aligned with the top of our assembly actually, with the tri-ball there. And now I'll choose a distance for this to be from the edge. So I'm going to right click and select edit distance from point and say this should be, for example, 100 or maybe 200 millimeters in from that edge. And then I'm also going to cut a hole here in this. And we can see because that's actually linked to all the parts, it's going to be creating a hole in all of them. So we may actually want to unlink the rest of those parts so that we can just have a hole in this one only and not the rest. But in this case, I'll just leave it as is and just leave the hole there in all of them. Just for this example. I'll move that to the center and we'll make this hole, say, 15 millimeters. And then we'll go ahead and add a hole to this too. So I'll add a hole here. And again, I'm just placing this hole randomly, but we could of course position it precisely using the tri-ball, choosing exactly where we want it to go, like in this case, to that midpoint, and a distance from point here of, for example, 100 mil in. So now I'm going to add two constraints to this. I'm going to add a positioning constraint that will make this internal face concentric to this internal face. Clicking OK. So now that will rotate, and if we turn on mechanism mode, you'll see how that works. But we do need to add one more constraint, which we'll add in a moment. But you can see now that works and rotates like that. There's actually nothing fixed in the model, so you can see the model's actually moving as well, which we don't want. We'll want to fix something in a moment. But as you can see, that's moving like so. And it's moving back and forth too, which we don't want either. So I'll show you what we're going to add to that to control it in the way we want. I'm going to select onto this base assembly, for example, and fix that base assembly in parent. So it stays where it is, and everything sizes upwards around that base assembly. So now if we turn that on, the other model won't move, but you can see this is still going through the model, moving in that direction, which we don't want. So we'll simply go in and add a new positioning constraint to go from here to here. And in this case, I'm going to create a distance constraint. And by default, you can see the number there is 343.514. But I'm going to actually click down onto those parts. You can see now that constraint shows, and I can double click on it and change that. So I'm going to create a 2 millimeter offset there. So there's just a 2 millimeter gap now between those two parts. And now if we turn on mechanism mode, we can now rotate that, and you can see it's now only moving in the direction we chose there, which is the expected movement. Now you can go into far more detail, for example, limiting the movement as well. In this case, I'll show you how to limit it with an angle constraint. We'll go to the annotation ribbon tab here, click on angular, and then I'll click on this face and this face. And you can see that's currently sitting at 180 degrees. And now I'm going to right click on that and we'll lock it. And then once we've locked it, we'll actually go in and double click on it and lock it here so that we can see more options when we double click on it. And then we'll click on set limits. And that will allow us to set various rotation limits. So you can see it's currently at 180. Maybe we'll make it a low of 90 and or we can just see how that goes there, and a high of 0, or we can say a high of 180, what it is right now. So if we set it at that, you can then see when we turn off that tool, jump back into mechanism mode, you can see that well, actually for the constraints, you can see that's gone red because it's currently breaking that constraint. So we actually just need to change its position a little bit here. So if we try it now, once we've exited out of there, now it's placed in its correct position, and you can see it's going to go to flat and up to there and then stop. It's locking itself once it hits the top there. I can't move it any further that way. What I could do, for example, if I delete that and You can see now it's in a more useful position here at 90 degrees for us to now go in and constrain it a little bit better than before. Because it was at 180 degrees, it's a little bit harder to know which direction it's going to go and that sort of thing. Because it's at 180, so it could really go either direction. So it's easier if it's at 90 like this for us to then add, for example, from here to here. You can see that's a lot kind of more obvious of a dimension to customize as the user. So now I'll lock that, and I'll set the limits to be 180, for example, will be the high, which means it can go to flat, and the low can be 90, or maybe we'll just, in this case, we'll make it 100. So, 80 actually, so it can go back a little bit. And we'll hit apply. And now you can see, when we go to use mechanism mode on this part, we can go in this direction, like so, and it'll stop there. It'll lock itself, and then we'll go back this way, and it'll lock itself there at 80, just beyond the 90 degree point. Again, we'll click and drag, rotate down there, and lock it like so. We do have various other options for mechanism mode, like collision detection and display, but I won't go into detail in this video on the collision detection. That will be available in the mechanism mode video. Thanks for watching. That's how to use the positioning constraints tool.